Hello all, today in this video I am going to make a demo for ANN with Nadam Optimizer with the same code. We have worked with some other different optimizer, and here in this code we are going to make a comparison of the different optimizers. For that, initially we have imported the libraries what we have needed. Then we are just loading our data set. The data set which we have used is heart disease data set which we downloaded from Kaggle. We can just give us heart disease data set detection in Kaggle means you will just get this data set. The data set which we are using is having nearly 14 entries. Among that, the first 13 entries we will be using as the x variable, and the last entry, that is the target one, we will be using as the y variable. Then we are getting the info of the data set. From that, you can notice that every variables are integers apart from only one variable which is a float one. Then we are describing our data set. Then we are checking whether our data set is having any null values, because if it is having any null values means we have to work with so many pre-processing functions. Then we are displaying the heat map of the data set. Then we are determining the x variable and y variable. As I said previously that we are omitting the target variable in determination of x variable, and we are using only the target variable for the y variable. Then by use of this x variable and y variable and the test size as 0.2, that is 20% for testing and remaining 80% for training, we are working making variables like x train, x test, y train and y test. Then we are using the standard scalar for converting the vectors for the variables x train and x test. Then we are determining the shape. Why? Because the shape we will be using in the layer description. Then we are determining our layers. Here you may notice that our ANN is having nearly 4 layers. First is the sequential layer, then is the 3 dense layer. Among that, the first two dense layer is having the input dimension as output dimension as 11. Then the final one is having the output dimension as 1, because our work is a binary classification work. In the binary classification work, we will give the output dimension as 1 only. If it is multi-class classification based on the classes, we will just make it dimension. Here for the first two, all the layers uses the kernel initializer as uniform. Then the first two dense layer use the activation function as ReLU. The last one uses the sigmoid. The input dimension is 13, which is the one which is the shape of the data set. Then we are compiling our model by using the optimizer. Here we have used the Adam and the loss as binary cross entropy and metrics as accuracy. Here we are using early stopping, which will monitor the variable like validation loss. You can give some other variable also. Here I have given validation loss, and it will just make it will check the whether validation loss is changing or not changing for 10 approaches. Why 10? Because here 10 patients we have given as 10. If you want for some other approaches means you can just change the patient's value as per your wish. Then we are just training our model by using the fit function and with the variables x train, y train, then the validation data like x test and y test, then approaches as 50, and the callbacks we are using as early stopping. Then we are determining our classification report variables for Adam optimizer as precision, recall, F1 score and support, and we have got an accuracy of nearly 92%. Here it has worked for nearly 50 approaches. So the early stopping is not taken into action. Why? Because you may notice that it will notice the validation loss only. Here you may notice that validation loss is having some change. It is not showing, it is having some change, so it will not early stopping will not make its action. If it is not working, not changing for many for consequently 10 approaches means only validation loss will make its action. Then we are making a definition for the confusion matrix, and then we are just creating the confusion matrix of Adam as per like this. We have used for SDD optimizer. The only change is the SDD optimizer we will give us a SDD. Here the early stopping has worked. Why? Because if you notice notice the validation loss, it is not showing much difference, only 0.102.2 difference is noticed. No, so here it will the validation, the early stopping has made its action and it has stopped to at approaches 11 by 50, and we are getting the classification report and accuracy as 48, and we are displaying the confusion matrix. Then we have worked with rmsprop optimizer. The only difference is the optimizer is rmsprop. Here the early stopping has not made it actions, because you may notice in validation loss there is some huge difference. So early stopping is not making its action. Then we have determined the classification report and got an accuracy of 90, and this is the confusion matrix for it. Then we have worked with adadelta optimizer, and the only difference is the optimizer we are giving us adadelta. Here also the confusion early the stopping is not making us action since validation loss is changing. But for I think in the last 10 approaches it is same only. It is same only, but validation early stopping is not making any option, any action. Then the our accuracy is 49%, and this is the confusion matrix. Then we are worked with the adagrad optimizer. Here early stopping is made this action and its accuracy is 48, and this is the confusion matrix of it. Adamax, here the early stopping has not made it action and its accuracy is 88%, and this is the confusion matrix. And now we are going to work with Nadam. Nadam, you may notice that the confusion matrix, the early stopping has not made it action, and we have got an accuracy of more than 90. While displaying the classification report, we are getting an accuracy of 90, which is more or less equal to Adam optimizer. Then we are displaying the confusion matrix. Then we are making the comparison of all the optimizer which we are making so far. So here this is the comparison graph. Here you may notice that previously Adam was only having some best accuracy, but now Adam is making some merging at some point. So both Adam or Nadam is providing some better results only in terms of both accuracy, and also you can notice here also the Adam and Adam is merging. So in the next video we will be working with some other optimizers. Thank you.